Hi everyone, I am Vaishakhi, and this is my welcome to my love letter to muddy mosquito-filled spectacular forest. Today we are talking about mangroves. They are not just trees. We are talking about how satellite, drones, and a little bit of AI helping us to see their hidden struggles. Because let's be honest, wading through crocodile habitats to count leaves is not everyone's dream job. So let's look at them from the evolving state. So mangroves, the blue carbon guardians. So first thing first, what is even a mangrove? They are the salt tolerant trees which grows in tropical areas. Mostly globally we have around 1,47,000 square kilometer of them, and India holds about 3% of Southeast Asia's shares. But size is not everything. It's what they do matters, and they do a lot. And Here is the values. Mangrove stores 3 to 5 times more carbon than tropical rainforest, and they're worth a staggering $32 billion annually in fisheries, storm protection, and water filtration. And they also have various kind of other provisional services. Other, if we look at them through sustainability, so they provide a lot of provisioning services, other services. But here is the bad news. We already lost 35% since 1980s, and that is like one third of their total during my parents' lifetime. So here the loss of health doesn't mean the loss of means loss of all these services. So, which brings us to the $1 million question: how do we monitor health across this vast and inaccessible areas? So, here is the hard way: the traditional field-based health assessment, where we do through quadra sleeve sample mud core. And I have massive respect for field biologists. They are the real heroes. But this approach is time consuming and is point based. We can only cover a few parts of the total mangrove. But this app, and it simply doesn't scale. We have to extrapolate the data throughout the mangrove. So you can simply sample every hectares of 10,000 acres of forest. So we need a bird's eye view. So here come, before jump into the tech, what is even health? It is not just green means good. It is a multidimensional. We look at structure, how tall it is and how dense it and physiologically, is it photosynthetically doing well? And biophysically stuff like leaf area index and disturbances, has it cyclone or paste heat it. So remote sensing let us measure all four simultaneously, and that's the magic here. So let's comes to our integration, where we combine all these satellites, drone, and field data to enhance it, and we take ground data for training and pair it with drones for ultra resolution, and top it off with satellites for bigger picture. So when you fuse these three layers, you get a synoptic health map, a complete color coded report card for an entire forest in one image. And this is where the conservation meets data science. So here comes our workhorses, Lancet and Sentinel. And Lancet is like old and reliable because it has a 50-year of history and 16-day revisit time with a 30-meter of resolution. And Sentinel is new. It just launched in 2015, and it has a 10-meter resolution and 5-day revisit time. So, plus it has red edge bands specifically designed to detect the plant stress. Together, they are Batman and Robin of the mangrove monitoring. So, here comes the game changer, Google Earth Engine. So, earlier what we have to do, like we have to download terabytes of data, and it uh, your laptop would cry and you have to wait for few days to process those datas. Now I can write only 10 lines of codes and run it and process the decades of imagery in under a minute. So petabyte of data, zero download, and lightning fast analysis. And it democratized uh, satellite data for everyone, and even for grad student like me. So here comes the satellites are great, but they miss the fine details. That's where drone comes in. They do centimeter scale resolution, and we can build a 3D canopy model using structure for motion, especially turning the thousands of photos into 3D digital tree. And they also validate our satellite data. Think of drones as the ground truth team without the leeches and the mud and the crocodiles. Absolute lifesaver. And these are some paper which shows the use of drone use in this mangrove field. And here comes few case studies. It is in Australia. Its survey was dieback disease in mangrove, and how much it affects the total area. We can simply see through the map. We don't have to put so much of through data and tables. We can simply visually observe through it through the map. And next case study is from Mumbai, where I study now. So it is a case of defoliator outbreak, which is a pest, Hiblia puria. So it impact in this paper they cited like a 67.9% mangrove were defoliated. And what they did, this helped local authorities to pinpoint which creek zones were hit hardest, and so they could plan a restoration effort smartly. So from this picture itself, we can see that how much area these red points are highly infected and yellow are less infected. So from here itself, we can manage them through policy regulations. And here comes the future where we can integrate model like SATME, which have pre-trained on global satellite data. This means we don't need a tons of local field data to train models. And digital twin, it is like imagine a 3D stimulator where we ask what happens if sea level rise by 1 meter, and get an instant visual and ultimately unified health index, a single global score for every mangrove forest on the earth. That's a dream because it is still for global. There is no single unified health index for mangroves. So, but in this study, there are few challenges like cover, spectral saturation through high biomass canopies, persistent cloud cover in tropics, and tidal fluctuation mask the health signals. And sometimes we cannot reach the particular ground and to verify the exact data where we are collecting, where we are working through satellites. So this ground data is lacking. So here comes a takeaway message to wrap it off. Mangrove are the places where land meets the sea. So they holds they are protecting us from cyclones and different disasters, natural calamities. So with satellite and AI and a little bit of cloud computing, we have the tools to listen to their silent scream. And thank you so much for having me. Mangroves can speak, but their data can, and we need more brilliant mind to decode it. And reach out to me at email on your screen, and find me on through this wildlife website. And I would like to collaborate because I am from fisheries background and I don't have that much knowledge about the coding and all. So we can collaborate through coding because I am a biologist, I am not a coder. So we can collaborate. Thank you.
Thank you so much. That was a great talk. We don't have any questions in the chat, but if there are any, please add them to the chat, and maybe you could answer them directly into the chat as we move on. But thank you
Okay.
so much. That was great.